ever wondered how an artist can take a tiny little sketch and blow it up into a giant, perfect mural on the side of a building? Well, it's not magic, but it's pretty close. It's all about a super powerful tool in geometry called the scale factor, and today we're going to master it.
So what is the secret, right? How do you make something bigger or smaller but keep it looking exactly the same? Just a different size. How do you avoid that weird stretched out look when you resize a photo? Well, the answer is actually really, really simple. It all comes down to one thing.
And that answer is a single magic number. Seriously. This one number is the key to making anything scale up or down perfectly, whether it's a little drawing on your computer or the blueprint for a skyscraper. And that magic number? It's called the scale factor. And the most important word on this screen is multiply. That's all it is. You just take your shape's measurements, multiply them by the scale factor, and boom, you can scale it up or down without messing up its shape. Okay, let's see this thing in action. First up, we're going to look at how to make shapes bigger. This is called enlargement. It's exactly what you do when you zoom in on your phone. So for our first example, our scale factor is going to be 2. Now, here's the first big rule. Since this number is bigger than 1, you already know the shape is about to get bigger. It's that simple. All right, let's walk through it. Step 1, we've got our original shape. A little rectangle that's 2 squares wide and 3 squares tall. Step 2, we pick our scale factor, which we set as 2. And now for the important part, step 3, we multiply times every single measurement by 2. So the width, 2 times 2, that gives us a new width of 4. The height, 3 times 2, gives us a new height of 6. And last, step 4, we just draw our new, bigger rectangle with those new dimensions. And check this out. You can see it right here. The width doubled from 2 to 4. The height doubled from 3 to 6. It is the exact same rectangle, just proportionally bigger. No stretching, no squishing. Perfect. Okay, so we've made things bigger. What about the other way around? Let's dive into making shapes smaller. This is called reduction, and you're about to see that the exact same logic applies. This time, our scale factor is 1/2, or you can think of it as 0.5. Now, because this number is less than 1, we know our shape is going to shrink. That's the second big rule to remember. The process? You guessed it, it's exactly the same. We start with our shape, this time a triangle with a side that's 6 units long. We apply our new scale factor, 1/2. Then we just multiply. The 6-unit side times 1/2 gives us 3. We do this for all the sides of the triangle, and then we just draw the new shrunken version. And just like that, the whole triangle has been reduced. Every single side is now exactly half of what it was before. The proportions are perfectly preserved. So by now, you're probably starting to see a really clear pattern, right? Let's just lay it all out there. This is the big aha moment. This is your ultimate cheat sheet for scale factors. I mean, look how simple this is. If your scale factor is greater than 1, it's an enlargement. The shape gets bigger. If the scale factor is less than 1, like a fraction, it's a reduction. The shape gets smaller. And what if the scale factor is exactly 1? Well, nothing happens. The shape stays the exact same size. So cool, right? 3 simple rules that cover everything. Okay, we've got the rules. Now it's time to put them to the test. Let's do a quick practice round just to make sure all of this really sticks. All right, here's the challenge. We've got a square and every side is 5 units long. Your job is to figure out the new side length for 3 different scale factors, 3, 1/5, and 1. Think you know what's going to happen? Okay, first one, a scale factor of 3. We know 3 is greater than 1, so it's got to get bigger. We take our side of 5, multiply by 3, and we get a new side length of 15 units. Exactly what the rule predicted. Next up, a scale factor of 1/5. That's definitely less than 1, so we're expecting it to shrink. We multiply 5 by 1/5, and our new side is just 1 unit long. A perfect little tiny square. And for the last one, the trick question, a scale factor of exactly 1. We multiply 5 by 1, and of course, we still get 5. Just like our golden rule said, there is absolutely no change. And really, that's the whole secret. The source material for this whole explainer puts it perfectly. You've just mastered the basics of scale factors. It's all about multiplying by that one magic number. So I'll leave you with this thought. Now that you know the secret of this magic number, where are you going to see it out in the wild? Think about it. Maps, model airplanes, blueprints, even just zooming in on your phone screen. Scale factors are everywhere, doing the invisible math that shapes our world.